Everyone, in today's video, we will be going over the answer key for problem set 4. Problem set 4 revolves around the idea of measures of variability. And variability is the extent to which data points in a data set differ from each other and from the measures of central tendency of a data set. And so, whereas in chapter 3, we learned how to calculate the mean, median, and mode values, measures of variability really help us contextualize our overall distribution. And so with that being said, let's start off with question number 1. Given the following test scores, answer the questions below. Starting off with our first component here is what is the range of scores on exam 1? The range is a measure of variability that allows us to evaluate the full scope of our distribution. And so in order to determine that, we need to take the value that is the highest within our sample and subtract that by our lowest value within a sample. And so taking a look at the range of scores here on exam 1, the individual who scored the highest is Rachel. She received a score of 9.5, and so we're going to use her value here first. We then need to subtract that for the individual that scored the lowest, which was Tony. He received a score of 2. So if I do 9.5 and subtract that by 2, I get a total range value of 7.5. And so that is the distance between our highest and lowest value. It gives us our entire range of the distribution. Everything will be contained within that 7.5 value range. Moving on to our second component here, what is the range of scores on exam 2? And so these are different scores than on exam 1, and we see that Bobby actually scored a 10 on exam 2, and so he represents our highest value. We then need to subtract that by our lowest value, which in this case was Teeny, who scored a 3. And so if I take Bobby's high value of a score of 10 and subtract that by 3, I get a range of 7. Moving on to question number 2. This is probably the newest information, hopefully to you, that we've covered so far, and this is calculating the standard deviation by hand. I showed you 2 different ways to do this. I personally find the table method a little bit more easy. I think it's easier to organize our data in this format. But if you are more comfortable with the alternative formula, feel free to use it. It'll get you the same answer. But for the purposes of this review video, I am going to go over the table method. And so starting off, let's read this question together. Calculate the standard deviation for the following number of arrests. You can use the table below if helpful, or using the alternative formula. And so what you saw on the original problem set was all of our individuals listed here and the number of reported arrests that they had. And so I see here that I have 8 individuals within this table. And so we will have to calculate both the deviation from the mean and square that for each of these values individually. Keep in mind that a deviation is the difference between an individual data point and the mean. And so our very first step here is to calculate our mean. So this is bringing together the information that we just learned in chapter 3 into chapter 4. So recall that to calculate our mean, or the average of the sample, we need to add together all of the values and divide by our n, or how many individuals there are within our distribution. There were 8. And so if I take the total number of arrests, which was 32, if you add all these together and divide by 8, I get a mean value of 4. The second step is then to subtract the mean from each observation. So using the table method and knowing that our mean value is 4, you can double check your work here. Each of these values should be subtracted by 4. So all I'm doing here is taking my original value of number of arrests and subtracting it by 4. So this is consistent the entire way down for each of our 8 observations. Our next step is to square each of the differences. And so keeping in mind that when we square a number, it will always end up being positive. So all of your numbers here should equate to a positive number. If it didn't, we essentially wouldn't have a total, right? Because it would just be flip-flopping either each way, and they would essentially cancel each other out. And so that's why we have to square these values, or the distance away. And so when I do that, again, you can check your math here for each of those squared values from the deviation that we just calculated in this column. And you should receive a total value of 44 because once we square all of these, we have to add them all together. So you should get 44 here. We then divide by the number of observations in our sample minus 1. And so taking a look here at step 5, I took 44 divided by n minus 1, which is 7. And so if you do 44 divided by 7, you should receive a value of 6.286. Our last step here is to take the square root of that value. And so if you do the square root of 6.286, you should receive a total value of 2.507. And so the standard deviation for number of arrests is 2.507. Keep in mind and reference back the PowerPoint if this is helpful for you. If we were to have stopped at this stage here, this value of 6.286 represents our variance. So the only difference between our variance and standard deviation is whether or not we take the square root. And so you calculated actually here both the variance and standard deviation. And if you were to have stopped right here, if I would have asked you to calculate the variance, you would have stopped at step 5. If I asked you to take it a step further to determine our standard deviation, you would just have to take the square root of the variance. All righty, question 3 and 4. This has to do with the idea of adding, multiplying, subtracting, and dividing values from an original distribution. And so oftentimes we can see this when we make policy changes or we're converting data from one measure to the next. And so let's take a look at question 3 together. The Belle-Noire City Council reviews the average number of police stops per resident and determines it is too low to deter crime. As a result, they implement a new proactive patrol policy that increases the number of stops by an average of 2 for every individual in the dataset, regardless of prior levels of interaction. What does this policy change do to the mean and standard deviation of police stops? And so, taking a look here, what we're really evaluating is what adding a value of 2 would do to a distribution overall. And so we don't actually have to know what each individual within the distribution actually received because it's going to have a uniform effect on all of the values. So even though I worked through the math on the PowerPoint that you may have seen for this chapter and lecture video, here you don't actually have to know and work through the math in order to answer this question. So let's start off with what this would do to our mean or average value. If each individual's number of police stops increases by 2 as a result of the new proactive patrol policy, the mean will also increase by a value of 2. Adding a constant to every value in a data set shifts the entire distribution by that amount, so it will directly increase that average. Keep in mind that addition and subtraction are gonna operate the same here. And so if I would have said that they were planning to reduce the overall number of traffic stops by 2 because they were actually over-policing the community, all of our individual observations would also decrease by a value of 2. And so our average would decrease by a 2. And so, again, adding a constant to every value in a data set shifts that entire distribution by that amount, whether we're adding or subtracting. It does have a different effect here, though, for our standard deviation. The standard deviation will remain the same. The reason is that the standard deviation measures the spread or the variability of the data, and adding a constant to all those values does not change how spread out the values are from one another. Therefore, while the mean increases, the standard deviation remains unaffected. And so keeping in mind here, just draw up any distribution that you have in your head. It may be helpful for you to have a bell-shaped curve just because it's our most normal one that we have. If the mean, median, and mode was 3 police stops in this question, and we added 2 to all of them, our distribution would merely increase by 2. So that's what is happening to the mean. But because we're essentially just picking it up and moving it over, the distribution and the variability of those observations doesn't change. We're simply just shifting the curve from one place to the next. So that's why our x-axis would change, so the average would change, but the distribution and the variability would remain the same. Let's take a look at question 4. 2 years after implementing a policy to increase proactive policing, Missouri's Department of Public Safety decides to convert their data on the number of police stops per person from a yearly to a monthly format. To do this, they multiply every recorded value by 12. What does this policy change do to the mean and standard deviation of police stops? For this example, we are assessing whether or not multiplying our original value will change either the mean or standard deviation. And so question 3 was evaluating what would happen if we add a value, but subtracting it would also have the same effect. Here, multiplication and division go together. And so if I were to have asked you to go from a monthly format to a yearly format, we would have divided, and it would have had the same effect on both our mean and standard deviation. So just keep those two elements in mind, that the addition and subtraction go together, and the multiplication and division follow the same patterns as well. So let's see what this does to our mean. Our mean is going to increase by a factor of 12. So the mean increases because multiplying every value in the data set by a constant directly scales the average by that same amount. And so let's say that it was 4 in this case, and we were to change that from our yearly format into our monthly format, we would simply do 4 multiplied by 12 to get 48. But since we're doing that consistently and uniformly across all of our values within the distribution, it will have the same effect. Taking a look at that example as well, if it was 4 per year and we needed to scale that to a factor of 12, it would be 48 months rather than 4 years. And so that's where that changes there. Standard deviation increases by a factor of 12 as well. And so this is quite different than what we see the effect of it being on our standard deviation for addition and subtraction. It also increases by a factor of 12 because the standard deviation, when multiplying all values by a constant, stretches the distribution proportionally. And so before, think on our x-axis, where above, just adding it by 2 is going to shift it over, right? If we're increasing it by a factor of 12 or multiplying it, it's going to stretch all of those values together. And so it has the same effect here on both our mean and standard deviation. And it would be the same case if we were to do division in this case as well. We would be doing it decreases by a factor of 12 if we were to have gone from a monthly format back into a yearly format. And so just keep that in mind. That may pop up on a future quiz, so make sure that you understand the difference between the two. You can also take a look back, if it's helpful for you to work through the problems that actually have values attached to it, to the chapter 4 PowerPoint. We go over what a policy change would do in terms of sentence lengths. And so that is something that you can take a look at as well if this was particularly challenging to you. If you have any questions about this particular problem set or any of the content from chapter 4, measures of variability, please let me know. Feel free to email me or set up an appointment with me. And as always, I will see you in the next video.